Hello everybody, in this video I'm going to go over APEX section 10.3.1 study, which is an introduction to optics. This is the part 2 video. Remember there are 3 videos for this section. So if you missed part 1, just pause and go back and watch that before beginning this video. Okay, in part 2 we're going to talk about mirrors. So there are 3 types of mirrors. There's plane mirrors, concave mirrors, and convex mirrors. So what a plane mirror is, this is the type of mirror you probably have in your bathroom, right? This is the one you see most often. It's a flat mirror, and it produces same size virtual images. Okay, so what I mean by that is if this is your mirror, and this is, you have, let's say, an umbrella on one side of the mirror, and this is where your eye is looking at it, okay? Behind the mirror, you're going to see an umbrella that's the same size, looks exactly like the umbrella that you have, okay? It's the same size. So the reason why this happens is because of that law of reflection, which we talked about yesterday, that when light bounces off the mirror, it produces that same angle, and as a result, you see an image that is the same size. When we say virtual image, that's what's behind the mirror. So this is not a real object. You don't have a second umbrella that's behind the mirror. So that's why we call it a virtual image. This side of the mirror would be the real side, okay? So that's what plane mirrors are. We also have concave and convex mirrors. So a concave mirror looks like this. I draw these lines on the back to show that that's where the wall is, okay? And it curves in. And then a convex mirror, it curves out, sort of like the opposite. Okay? And when we're analyzing these mirrors, you notice that these are sort of part of a circle. So if you were to continue this circle, this would be your center, okay? Now, if I draw a straight line here, connecting my center to the edge of the mirror, I'm going to label this C for center, and then halfway between the mirror and the center, I'm going to label F for focal point. Okay, and you can do the same thing here for a convex mirror. This would be your C, this would be your F. Okay, and C we call the center, F we call the focal point. So now when we're drawing these, you're going to draw a straight line, you're going to draw your mirror, and then you're going to include your focal point, your center, and this is called the vertex. So this point is called the center. Halfway between the center and the mirror is the focal point. And again, focal point is half to the center. This in the place where the mirror meets your line you drew is called the vertex. And this is the axis, that straight line that goes right through the mirror. Okay, so this is how we're going to be representing mirrors. We have concave and convex and plane mirrors. Plane mirrors are pretty simple, so we're just going to leave them off like this. And let's go on to talk about concave and convex mirrors. So when we're analyzing mirrors, it's useful to draw what we call a ray diagram. What a ray diagram does is it shows where the light rays are bouncing off of the mirror, and it helps you predict what kind of image you're going to see from the mirror. So when we're drawing a ray diagram, it's really important for you to use a ruler. So you can't see this, but I do have a ruler out. And first we draw our axis. Then we're going to draw our concave mirror like this. Make sure we have our wall. Okay. And then we put in where our focal point is and where our center. So we're also going to put it on the other side. So this side over here we're going to call our near. So the near focal point and near center, and this is our far focal point and far center. On this side of the mirror, this is going to produce real images. This is like a projection, okay, like you could use on a projector. The far side produces virtual images, just like you saw in the plane mirror. Okay, all right. So now you have your object. Let's say this here is our object. I usually represent them by an arrow, just because they're easier to draw than a whole object. So now what we're going to do is we're going to trace these 3 rays. So up here I've written down what rays you have to draw. So first you're going to draw a ray that is parallel to the axis that reflects through the near focal point. So we take our ruler, we make our ray that is parallel to the axis, like this, and then we reflect it through the near focal point. Okay, so like this, and then I'm going to draw this dotted line to show it continues behind the mirror. All right, that's our first ray. Now let's look at a second ray. A ray going through the near focal point reflects parallel to the axis. Okay, so this is going to be a different ray that is reflecting through the focal point. Okay, trying to get my ruler straight. Okay. So this is our ray. It's going to reflect up from here, from our focal point, and then go back parallel. Okay. All right, let's do our third ray, which is the ray coming through the vertex point. Remember, this is our vertex point in the middle. And it reflects out at the same angle it came in at. So the reason this is because at that very center of your mirror, that vertex, it's sort of like a plane mirror. So we can draw our angle going out, or I'm sorry, going into the mirror, and then the same angle bouncing out. Okay, and you can continue this line up, and we should see that all of these meet here at this point. Okay, so this is our image. So what we did here was we drew 3 rays, the ray parallel to the axis that reflects through the near focal point, then we continued it back behind the mirror. We drew the ray coming through the near focal point that bounced off the mirror and goes out vertically, and then we continued that back, and then we have the ray that comes in through the vertex and reflects at the same angle. Then we continue that back, and they all should meet at one point, and then you can draw a line connecting that point to the axis, and that would be your image, okay? So concave mirrors can produce very different images. Here we have an upright, virtual, and larger image, right? It's on the virtual side, it is upright, it is on larger than our original object, okay? So this produced an upright, virtual, larger image. Let's go through the types of images that concave mirrors produced. So okay, so if you have concave mirrors can produce real and virtual images, okay? And if the image is real, it's going to be upside down. So if it's on the real side of the mirror, it's going to be upside down, or virtual is going to be right side up like we just saw. Okay. So if you have a virtual image, it's always larger. And if you have a real image, it depends on the situation. So if your object is to the left of C, like it's right here, then it's going to be smaller. If you are at C, it's going to be the same size. And if you're to the right of C, it's going to be larger. Okay, and you could go through a ray diagram and see each of those findings. All right, so we need to be able to draw a ray diagram for a concave mirror by drawing these 3 lines. We realize that they can produce real upside down or virtual right side up images. And virtual image for a concave mirror is always going to be larger. A real image is going to be smaller, the same size, or larger, depending on where your object is. Okay. All right, now let's look at convex mirrors. So again, we're going to draw a ray diagram to analyze a convex mirror. So we get out our ruler and we draw our axis. Now we're going to draw our convex mirror. And make sure we are labeling where our focal point and our center is on both sides. Okay, all right. Now let's put our object here. Now the rays we're going to draw are very similar to what we just talked about with concave mirrors. So the first one is our parallel ray reflects as if it came from the far focal point. So this is slightly different. So this is our parallel ray. In the concave mirror, we drew it like this, like it came from the near focal point, but we're not going to do that. We're going to say it's coming from the far focal point. So that's on the other side of the mirror. So we're going to go like this. Okay. Okay, the next one. A ray going towards the far focal point reflects parallel to the axis. Okay, so let's do this. All right, so we're lined up as if this is going towards that focal point, right? And then when it hits the mirror, it reflects off parallel to the axis. Okay. All right, and now the last point here is a ray coming in through the vertex point reflects out at the same angle. So this is exactly the same as for concave. We have it go in and it bounces out at the same angle. And we can continue this back. And we notice that these all converge right here. So this is our image. So it is a virtual image, and it is smaller, and it is upright. And what we will notice about convex mirrors is that convex mirrors can only produce virtual smaller images. Okay. All right, so that's everything about convex mirrors. So what we need to know from this section is we need to know that there are 3 types of mirrors: plane mirrors, concave, and convex. We know plane mirrors are flat mirrors. They always produce same size virtual images. We need to know the difference between concave and convex mirrors. Then we can draw ray diagrams for both concave and convex and identify if the image created is virtual, real, upright, or inverted, virtual, real, or larger or smaller. Okay? So that's it for mirrors. Come back tomorrow and we're going to talk about lenses.